Hello and welcome to the second lesson in the series on linear functions. In this lesson, we're going to be drawing a graph of the function we worked with in the previous lesson. By the end of this lesson, you should be able to identify the gradient of a linear graph and identify the constant of a linear graph. We can mark points that relate two values on the Cartesian plane. And creating a graph is a powerful way of representing a function. So let's have a look at a Cartesian plane. We represent the input values on this horizontal line, which we call the x-axis. And in this example, the x values are the duration of calls, which are given in minutes. We represent the output values on the vertical line, or the y-axis. And remember, the output values here are the total cost of the calls given in Rand. And in this case, I've chosen to use a scale where each block represents 5 units, as this will allow me to estimate accurately enough for this example. We are going to use the values we calculated in our table to draw the graph of this function. Let's just recap at what those values were. For example, when the duration of calls is 10 minutes, the total cost is 28 Rand. And when the duration is 30 minutes, the cost is 44 Rand. So let's plot some points. Now I can plot the point where x is equal to 10 minutes and the cost is equal to 28 Rand, like this. Where x is equal to 12 minutes, the cost is 29 Rand 60. So the y value is closer to 30, round about over there. Another point is where x is equal to 30 minutes and the cost is 44 Rand. So that point lies up about there. Now I can carry on and plot points for x is equal to 20 or x is equal to 40, etc., etc. Now if I'm working accurately, the more points I plot, the more obvious it will become that these points lie in a straight line. In other words, that this graph is linear. Let's have a look at the table of values from our first lesson again. We saw in the table that the difference between two consecutive output numbers is constant. It is always 0,8 if the difference between the input values is 1. This is the definition of a linear function. A linear function always has a constant rate of change. Now we know that in our formula the rate of change is a constant, therefore we know that our graph must be a straight line. Let's take a look at our graph again. You can imagine that the more points I plot for different times, the closer together these points will lie. And eventually I'm going to have so many points so close together that they will form a continuous line. I could calculate the cost of any call for any duration, whether it's 22,3 minutes or 12.5 minutes. So by that logic, I'm going to join the dots that I already have rather than plotting all of the points possible. So if I were to complete my graph, it would look something like this. But it's always important that we label our graphs, and in this case, this is the graph of y is equal to 0,8x plus 20. This line graph is then a neat package of all of the possible duration of calls and total costs. But you must note that here we only see a part of the graph. This arrowhead tells us that the graph continues for as far as we care to look. Do you know what the points on this line mean? How do we interpret a graph like this? I can choose a point anywhere on this line, say this point over here. And if I move down to the x-axis, I can read off the duration of calls for that point. Here it is 25 minutes. If I go across to the y-axis, I can read off the total cost. Here it is 40 Rand. So, when the duration of calls is 25 minutes, the cost is 40 Rand. Now surely, if this graph contains all of the information about the relationship between the duration of calls and the total cost, then it should also contain information about the cost per minute, or the rate of change, as well as the constant amount that we need to pay for renting the telephone line. We just need to know where to look. We know that that formula is given by y equal to 0,8x plus 20. In this formula, 0,8 is the cost per minute of calls, and 20 is the fixed cost of renting the telephone line from Telecor. Let's see what the relationship is between this formula and the graph that we've plotted. To start with, we plotted points for which we calculated y values by using exactly this formula. That means that if we choose any point on this graph, the values of that point must make this formula work. Let's check that by using a point which we don't have values for yet, but which we can read accurately from the graph. This looks like a good point here. It's the point where x is 25 minutes, while the y value is 40 Rand. Let's use these values and see if they satisfy the formula. So in terms of our formula, we know that y is equal to 40, so the left-hand side is 40. Now our formula says that y is equal to 0,8x plus 20. So we need to get an answer of 40 out of the right-hand side of our formula using an x value of 25. Let's check that. The right-hand side is therefore equal to 0,8 times 25 plus 20. Now 0,8 times 25 is equal to 20. So the right-hand side is equal to 20 plus 20, which is 40. It's the same as the left-hand side. That means that this point, x equal to 25, y equal to 40, does satisfy our formula. In other words, it makes our formula work. Now, this should also mean that if we choose a point which has an easy to read y value, but an x value that falls between the lines, we should be able to use our formula to find that exact x value. Let's take a look. So if I choose this point over here, I can easily read the y value off as 50 Rand, but the x value I'm not quite sure of. So I know that the total cost is 50 Rand. Now I can write an equation. We know that our formula is given by y is equal to 0,8x plus 20, and we also know that the value of y is equal to 50. So therefore I can write the following equation. 50 is equal to 0,8x plus 20, and use this equation to find the value of x. The first thing I'm going to do though is subtract the cost of renting the line from both sides of the equation. So therefore 50 minus 20 is going to be equal to 0,8x. Therefore 30 is equal to 0,8x. So that means that the number of minutes, or x, multiplied by the cost per minute, or 80 cents, is equal to the total of 30 Rand. We can estimate our answer. 10 minutes at 80 cents per minute is a total of 8 Rand, but that is much less than the 30 Rand total that we need. If I tried 40 minutes, also at 80 cents per minute, that is a total of 32 Rand, which is just slightly greater than the 30 Rand that we need. So therefore, I expect our answer to lie somewhere between 10 minutes and 40 minutes, but to be much closer to 40 minutes. So let's calculate how many 80 cents there are in 30 Rand. So that is 30 divided by 0,8, which is 37,5. So therefore we know that X is equal to 37,5. Let's see if the graph shows that too. If I read down from my point to the x-axis, I can see that my value lies somewhere between 35 and 40, although my scale is not fine enough to give an accurate reading. Graphs and formulae are useful under different circumstances. We can get quite accurate answers out of a graph depending on the choice of scale that we make. But very often a graph is a quicker way of getting information about the relationship between variables than a formula. So just by looking at this graph, we can see that the total for a duration of calls of 40 minutes will be something just slightly above 50 Rand. The formula can help us to get an exact value. Just by looking at the formula, we cannot tell that the total cost for 40 minutes worth of calls is about 50 Rand. But the formula does tell us that the rate of change, or the cost per minute in this case, is 0,8 Rand. On the graph, the rate of change cannot so easily be seen. It needs a little bit of work. Let's see if we can calculate the rate of change using our graph. The scale on our graph does not allow us to take accurate readings of consecutive minutes, like 11 minutes and 12 minutes. So let's choose values that make the calculations as easy as possible. And we can choose any 2 points we like. But I'm going to be working with x equals 0 minutes and x equal to 25 minutes. So the change in the input values is 25 minutes. Let's see what the corresponding difference is in the output values. Well, at 0 minutes, the output value is 20 Rand, and at 25 minutes, the output value is 40 Rand. So there is a change of 20 Rand in the output values. We know that the function is linear. That is, we know that the rate of change is constant. In other words, it's the same rate of change between any 2 consecutive points. So let's share out our total change in the output values between the change in the input values. 20 Rand divided by 25 is 0,8. And indeed, if we divide the difference in the y values between 2 points by the difference in the x values between the same 2 points, we'll be calculating the rate of change of that function. All that we now need to do is see where on the graph we can read off the cost of renting the telephone line. In the formula, it is the constant number 20 that is added. Well, let's think logically. We will pay 20 Rand for the telephone line even if we do not make a single call during the month. We represented the duration of calls on the x-axis. So let's now see what the reading on the y-axis is when the x value is 0. So it's this point over here, and we can clearly see that the value on the y-axis is 20 Rand. Using graphs is often a good way if we want to estimate values at a glance. But if you want to find accurate values, then it's always best to use the formula. Join me next lesson, where we'll have a look at finding the formula of straight line graphs.